Hello everyone, welcome back to the channel. I hope you guys are doing really amazing. So welcome to the video 10 of the dynamic programming playlist where we are talking about currently on DP on grids, and probably this is our last video of DP on grids, and we want to do today not so difficult. Okay, so we want to do a lead code medium problem, and it is not at all difficult, and it is rather a different kind of problem than normal DP on grids, which mostly involves finding path from start to end. Okay, so this is definitely a little bit different one. So you don't need to find any path or perform any kind of BFS in this DP on grids. So all you need to do is think little bit, and definitely, this is a more intuitive kind of problem, and this is not at all a hard question. It is a medium question, so you should definitely try it on your own. Okay, so the question is nothing but of maximal square. So let's see the question. If the problem statements looks really simple, you are given an m cross n binary matrix filled with zeros and ones, and you need to find the largest squares containing only ones and return its area. Okay, so you know the area of a square is nothing but the length of its side multiplied by the length of its side again. So square of the length of its side. So you see the largest square which can be got is with area equals to 4 in this grid, and in this grid it's just 1. So if you try to see that in this whole grid these two squares are the only possible cases where you are finding the squares where all the elements are one inside, and it is of the largest possible side of the square. Okay, so you need to return the area. So you see 2 cross 2 square has an area of 4, so you get the output of 4. So I want to think I want you to pause the video and think a little bit on how can we approach this question, and then continue with the video. Okay, so this is definitely a little bit more intuitive uh, problem and not at all difficult. Okay, so I want you to think without recursion. So generally I have told you, I had also shown you one DP on grids where you apply from recursion to memoization, and then again to the iterative version. But generally I ask you that DP on grid, you try to skip these two steps. You directly go to the iteration method, because it will be always beneficial, and there is no much use in following recursion, at least on this topic, DP on grids. Okay, so if you practice more and more question, you will really understand why I am telling this. So in this problem also, I will ask you to solve in the direct iterative approach without recursion or memoization. Use iteration, try to use iteration properly. And so you need to create a 2D DP, and you need to think what DP of ij would actually mean in this problem statement. Okay, so definitely pause the video and try to think what exactly are your objectives and what do you want to attain. Okay, what exactly do you want to attain? So after you have thought, let's continue with the video. You see, we want to find maximum area, right? What do we need to find? You want to find maximum area of all ones. Okay. Isn't it equivalent to finding maximum length of square? Okay, maximum side length of a square which consists of all ones. Okay, so this thing is very much equivalent to finding this thing. So definitely you can you can store your dpij with something like this. Okay, so what will is exactly store? So for instance, you can imagine your dpij stores the side length. Okay, so this side length of a square of all ones ending at I comma j in this cell. Okay, so in this particular cell, you want to store the side length of the square, which consists of all ones. So what do I mean by it? And now you try to imagine, after you thought what can be your possible DP state. Okay, so now you try to imagine what can be your DP transition. Okay, so what can be a possible DP transition? So first you try to draw some test case. Okay, so and try to imagine that what could have been my possible DP state if the matrix looks something like this. Okay, so you try to see this. Okay, so let's say your matrix has some values, and in this manner things are there. Okay, so and there are many zeros in fact, and you have some things like this. 1 0 1 0. Okay, so let's say this is your matrix. So now what exactly will your DP matrix store? If this is your original matrix, my question is that now try to think, this is your original matrix, right? So this is the original binary matrix. Now what exactly will your DP matrix store is the question. So what is the length of this? It is of 7 cross 5, right? That's what I made at random. So the DP matrix will also have the same thing. So just try to do it. 4, 5, 6, and 7. And I should draw 4 lines. 3 and 4. And this will be our DP matrix. Now, what does our DP matrix store? What does our states? So in the ending at the I comma j cell, store the side length of all ones. Okay, so you see what is the side length ending at a square. Okay, so you have a square of all ones, and in this point this square is ending. Okay, so this is our I comma j. So you see at this point what which square is ending? Is there any square? Okay, so you have only a 1 cross 1 square here which is ending, so side length is 1. Now at this point there is also a 1 cross 1 square. This whole thing 2 cross 1 thing is not a square. This is a rectangle, so the square is only this 1 cross 1. Okay, so you got 1 here, and similarly you got 0 here, you got 0 here, you got 1 here, you got 0, you got 0 1 0. I hope you understand. Now if you try to think on this position also, the square which is ending at this position is 1. Now you think at this position, the square which is ending is of size 2 cross 2. The maximal square is of size 2 cross 2. So instead of placing 1 here, you place a 2. And in a similar manner, you should know that this is also a square of size 1. This is a square of size 0. And that's what we have been doing. And this is also square of size 1. This will be also 1. Okay, so ending at this point, if you try to think, this is not a square consisting of all ones because there is a 0 here. So this 0 is here. So I hope you understand that and make it 1. This is 0, this is 0, this is again 1, and this is also again 1 because ending at this point, thus there is only 1. And you see when you come to here, you see now you get a 2 cross 2. So you get a 2 here. Okay. At ending at this point, you see you get a 2 cross 2 again. So you get a 2 there. Again, you get 0, 0, 0, 0. The things which are 0 will always be 0, right? Because it itself is not 1. So how can it be a part of a matrix which is ending at I and j and consisting of all ones, right? So this will be again 1. This will be again 2. So you see now this, I mean, this point is now having a matrix of length 3 cross 3. Okay, the square of length 3 cross 3, all of this is 1 and it's 3. Okay, so I hope while filling up the DP matrix, so what will be your answer in this case? Okay, so you iterate through all the I comma j values and find the maximum element. In this case, the maximum element is nothing but 3. And in order to find the area, you just do 3 square 9 will be your answer in this case. Okay, so the maximum square which you can achieve is 9. Okay, but in building the DP matrix, did you find any pattern? Did you find any pattern? We generally replaced ones with ones and zeros with zero, but we started to replace two only when, so let's say these three elements are when 1, we started to replace 2. When you see in this case, in some other cases where I mean to say, where 2 was there, okay, where these three were 2, you started to fill 3, right? You started to fill 3. So can you observe any pattern here? Can you observe any pattern? When should you increment your number, or when should you not increment your number? Okay, so this becomes really important. This becomes a really important one. And you see, when you have something like, you write a 1 here, but when you have something like this, but you still write a 1 here. Why exactly is that happening? So if you notice, if you take the minimum of these three values and add 1 to it, it is nothing but your next value. Okay, if you take the minimum of these three values and add 1 to it, it is nothing but your next value. How to understand this intuitively, right? So let's say this is your cell I comma j. Okay, this is your cell I comma j which you want to fill, and you have some cell which is ending at, let's say, 2. This value is, let's say, 2. Okay, so it definitely means that it has a, just a second, it definitely means that it has a square of all ones which is ending at this point. So you just draw that square. Okay, you just draw that square. Now if this value is also okay, so I'm drawing it in someplace else. So let's say this is also 2, this is also 2, and this is also 2. I am telling that this will be 3, right? So what does this mean? I am drawing it in a separate space. If this is the cell I comma j, if this is having 2, what does it mean? That it, in the actual matrix, it is having a square something like this, which is ending at 1. Okay, and this is having 2. It means that in the actual matrix, it is having a square which is ending at 1. Okay, so it has this square. Now this 2 means it is having another matrix which is nothing but looks something like this and consists of all ones. Now if this is also 1, you do get something which is greater than you. Now imagine a case where this is happening. Okay, so something like this, this is your I comma j cell, okay, in the DP matrix, and you have something like 2, 2 and 1. What are you supposed to place here? Should you place 2 or should you place 3? Now according to your thing, that minimum of all these values, what is the minimum for all these values? Minimum among 2, 2, 1 is 1, and if you add 1 to 1, you get 2. Okay, so according to our analogy, there should be 2 here. But how do we prove it? So we try to do that again. So what we try to do is that we try to prove it again. So uh, this thing is 2. What does it mean? Is that uh, let's say this is your I comma j cell, and the cell which is above it is having 2. It means that it has a matrix with size 1 cross of size 2 cross 2, which is of length 1. Okay, which consists of all ones. So now this is satisfied. Now this 2 implies that there will be a matrix something like this which will consist of all ones. Okay, now this one implies that there is only a single matrix of length 1. This one simply implies that. And if this is 1 also, it means that here it is must be 0 present, because if here it was 1 present, then this whole matrix would have been a square again, and you should have got a 2 here also. Since you have not got a 2 here, it simply means that you got a 0 in this place. And you see the maximum square ending at I comma j is not 3 cross 3 now. It is not 3 cross 3. It is just simply 2 cross 2. Okay, it is simply 2 cross 2 matrix. So I hope you understand this. You just need to take the minimum of the all the values and add, because in I comma j, if you got in I minus 1 comma j, this is I minus 1 comma j minus 1, and this is nothing but ij minus 1. If in all of these three previous cells, if you have filled with some minimum value, take the minimum value of all these three previous cells, and then only you can assure that you can write, I mean, another thing, you can go ahead of that. So let's see, what if it was 3? It means that it has a matrix like this. This is also 1. Okay, so this value, if it is 3, it means that it has something like this. But you see the minimum value among all of these 2 comma 2 comma 3 is nothing but 2, and you add 1 to the 2, you will get 3. So what will happen is that this value has also 3 in the TP, and that's because only this 3 cross 3 cell is available to it. Okay, only this 3 cross 3 cell is available to you. So I hope the DP transition is very much simple to you now. I hope things are really clear, and you can simply write the DP transition in this manner. DPIJ is nothing but minimum among DPI minus 1j. Okay, DPIJ minus 1 and DPI minus 1, J minus 1. Okay. If you just do this minimum value and add 1 to it, that will be completing your DP transition. And all you need to do is iterate through the DP, iterate through the modified DP and store the maximum value, maximum length value. And you just do length square when you return your answer. Okay, this will be your area. Okay, so I hope things are really clear now. The explanation was, I guess, really clear to you. So I will just calculate quickly. I will have take out the dimensions of the matrix N and M. Okay, so I do get the dimensions right now. And what will happen is that I just create a TP, which is of size MN. And I have a length, integer length. Let's make it 0 initially, right? Initially, we have a 0 length of square. Okay, now we want to find the maximum value. So I will just go through all the elements of M, and definitely I will also go in a J variable all the elements in M. So I'm iterating through all of the matrix. And you must have seen that on the first row and the first column, we just need to copy the values. So you see in the first row, all the values were same, okay, as the DP and the original matrix. In the first column, all the values are same. If you think intuitively also, if they are the ending points of a square, then you have only a square of size 1 cross 1 and nothing else. So you just need to copy the same value. Okay. So at first what you do, you just copy all of the same values, right? So you just do dpij is equals to matrix of ij minus 0, because it is, I mean, I don't know why, but they have given character instead of integer here. So this is dpij. I'm just storing integer values in dpij. And if I'm telling that if I'm not in the first row or first column, it means that if I is greater than 0 and j is also greater than 0, if both of them are greater than 0, then only I can write the dp transition. And it would simply mean that I have something like this: dp of I minus 1j, dp of I minus 1, j minus 1, dp of I, j minus 1, plus 1. Okay, so I hope this this dp transition is really clear to you. And now after you have modified your dp, you just update your length value. You just need to find which is your maximum length, right? I hope that is clear to you. And at the end, all you do is return the area of the square, which is nothing but length into length. I hope that also is really clear. So if you try to run it and check, uh, okay, so they are telling you not to initialize a variable length arrays. Okay, so what you can do is, I think it was working earlier when I uh, tried to write the code, but you can always make it a vector, right? M and vector of integer n. Okay, so I hope you initialize all of the values with 0 at first, and that's your TP matrix. If you just try to run it and check now. Uh, okay, so there are some errors here. You can easily understand that. Spelling was wrong. Okay, so we are actually getting some wrong answer right now. We will definitely check what is the error in our approach. So I forgot two important things to do. This matrix should have been matrix of zero because this is the number of rows and this says that how many columns are there in each row, how many values are there in each row. So you go to the first row and then find its size to find the second dimension, right? I hope that is clear to you. Okay. And definitely you can update this dpij only when dpij itself is 1. Okay, so you just need to ensure that dpij, if dpij is equals to 1, then only you just iterate, because if the current dp is 0, you can never get a matrix of all ones ending at that I comma j point, right? So I hope it was clear to you. Let's try to run it now and check if it works. So you see, we did get the accepted thing. If we try to submit, will it work? Let's try to see. So yeah, it got the accepted value and it does not have a very good runtime and memory complexity. But when I was running the code with exact same solution, you can see there are a varying memory and time complexity. Okay, so if you go to my submissions and check my solution, you will see that it has a 97% memory and 65% runtime with the exact same code. Okay, with this exact same code. There is no much difference. So yeah, I hope that was clear to you. I hope the approach was clear to you. And I hope similar problems you could also think in the same direction if any problems similar comes. Okay. So I hope this video was helpful to you. Definitely subscribe to my channel. It was, if it was. And so yeah, that's all. From the next video, probably we will be starting with DP on strings. So yeah, thank you so much.